There are so many peptides being talked about right now, but which should you focus on for longevity purposes specifically? i.e., which peptides have the best mechanisms and studied effects to potentially improve your health span and lifespan? Well, as a licensed medical doctor specializing in longevity medicine and certified in peptide therapy, I'm ranking my top 5 peptides for longevity in this video. And the criteria for how I ranked these is this. 1, how strong is their mechanism? i.e., is their mechanism one that would make it likely that they could actually improve health span or lifespan? 2, how strong is their depth and breadth of both preclinical and clinical evidence? 3, how large are the effects seen in these studies? And then 4, what is the risk to benefit ratio of using them? And all the peptides on this list are in the top 5 for different reasons. For instance, some have extremely good mechanistic rationale for improving lifespan, but they might have little to no clinical data, versus some others have significant preclinical and clinical data behind them for some specific aspect of aging. However, they might not have very good mechanistic rationale for extending lifespan directly. And it's also worth noting before we jump into the rankings that we're not going to cover the dosing, cycles, and full longevity stacks in this video. That is just too complex of a discussion to have here because we'd need hours to have it, especially since a lot of these ones are not FDA approved for human use. So future videos will cover optimal dosing, cycles, and the full risk-benefit analysis of each of these peptides on this list. And this video itself is more to show you which peptides show the most promise for longevity and why, to show you how they work, the data we have behind them, and thus who might benefit from each of them for longevity and anti-aging purposes. So without further ado, let's jump in with number 5, remembering that, of course, this is educational content only and not medical advice. Coming in at number 5 is MOTS-c, and we've already done a 30-minute deep dive on this one, so I'd highly recommend checking that out, and we'll keep it brief here. But MOTS-c is a 16 amino acid long mitochondrial derived peptide that's released naturally by your mitochondria in times of stress. Essentially, it's released in order to help your cells adapt to a stressor. That way, the next time that they are under stress, they'll be able to respond better. And MOTS-c triggers your cells to adapt chiefly through the downstream activation of AMPK. And this results in improved mitochondrial function, increased insulin sensitivity, improved burning of fat for fuel, and even decreased inflammation and oxidative stress. And all this adaptation that is triggered, again, helps your cells and your mitochondria to come back stronger. And because of all of this, MOTS-c is often termed exercise in a vial, because you're essentially training your mitochondria and training your cells. And there is definitely some overlap in the mechanisms behind how MOTS-c and exercise could be beneficial. After all, MOTS-c is definitely increased naturally when we exercise. But because of all of these positive adaptations that MOTS-c can trigger, you can probably start to see how it could be so beneficial for longevity purposes. For instance, it works on multiple of those 12 hallmarks of aging, or those root causes of aging, chiefly of which it decreases mitochondrial dysfunction, which is a driver of not only of aging, but also of many chronic diseases. So because of all of these effects, there have been a multitude of preclinical studies on MOTS-c's effects on chronic diseases and the aging process itself. And we talk about almost all these studies in our standalone video on MOTS-c. But briefly here, we'll talk about MOTS-c's impact on longevity directly. In one study in a mouse model of aging, MOTS-c was found to inhibit multiple aging-induced changes in the skin, liver, fat, and just metabolism in general. And then in another study, when MOTS-c was delivered late in life to mice, it was found to improve not only metabolic function, but also markers of functional strength, body composition, and movement markers. And when that same study looked at the lifespan of the mice, they found trends towards MOTS-c improving both average and maximal lifespan by about 7%. However, these changes were not statistically significant, partly due to the low sample size. But I definitely think this shows that there should be larger, higher-powered studies looking at MOTS-c's potential effect of lifespan extension, because I really think that MOTS-c does show some promise here. And then furthermore, there are also multiple studies on MOTS-c promoting skeletal muscle health with age and inhibiting muscle loss in mice, as well as studies on it inhibiting bone loss or osteoporosis in mice. And maintaining proper bone and muscle mass is super important when it comes to longevity. So this data even further adds to the case of MOTS-c as a longevity peptide. Unfortunately though, we don't have much human data on this one. Only one study on its analog, CB4211, in which it was found to significantly improve markers of metabolic syndrome, including lowering liver enzymes and lowering a fasting blood sugar. But despite the lack of human data overall, because of this promising preclinical data we have, as well as the promising mechanism, I still believe that MOTS-c deserves a spot on this list. And it especially could be a good add to a longevity stack for you if you're someone who struggles with some insulin resistance or metabolic syndrome. And it's also worth noting here that a close number 6 is SS31, the other mitochondrial peptide that we discussed in another deep dive video. To me, the reason that MOTS-c edges it out to be on this list is because of the data showing that MOTS-c can provide anti-aging type effects at any age. Again, due to the ability for MOTS-c to essentially train the mitochondria, compared to SS31, which just provides structural support to the mitochondria that is needed with aging. But that being said, SS31 does have much more extensive overall human safety data, so it really is a toss-up here between 5 and 6. But coming in at number 4 is FOXO4-DRI. And despite having limited evidence on its use, FOXO4-DRI makes it onto this list due to having probably the most exciting mechanism when it comes to promoting longevity, and that is by acting as a senolytic. And in general, senolytics are essentially things that can cleanly kill senescent cells, or the cells that have stopped growing and dividing properly. And this is important because when these cells are not killed properly, they can release inflammatory molecules that damage surrounding tissue and then further drive both chronic diseases and aging. And this is exactly why cellular senescence is one of the 12 hallmarks of aging. So by killing off these senescent cells, senolytics can work to directly inhibit the aging process and potentially even extend lifespan. And FOXO4-DRI is a synthetic peptide that was designed for exactly this purpose, to act as a senolytic. Essentially, researchers discovered that the naturally occurring FOXO4 is elevated in senescent cells. And within these cells, it binds up a molecule called P53 and keeps it within the nucleus of the cell. And this is problematic because by keeping P53 in the nucleus of the cell, the senescent cell is allowed to survive. And this is because if P53 makes it out of the nucleus, it can trigger something called apoptosis, or a clean killing of that senescent cell, which again is exactly what we want. So naturally the question became, how do we block FOXO4 from binding up P53 and keeping it within the nucleus? And thus enter FOXO4-DRI. And the DRI portion stands for D-retroinverso, essentially meaning that they took the FOXO4 amino acid sequence and reversed it, and then also for each amino acid used the D form instead of the naturally occurring L form. And this modification of the natural FOXO4 sequence, along with an additional added peptide sequence, allows FOXO4-DRI to effectively block FOXO4 from binding P53 and keeping it in the nucleus. Thus, P53 can exit the nucleus and trigger the killing of these senescent cells. And this is exactly why FOXO4-DRI is known as a senolytic, and why researchers and scientists are super excited about potentially using FOXO4-DRI to extend lifespan and promote longevity. However, as mentioned, we have pretty limited evidence on this one. We do have one study in mice specifically looking at FOXO4-DRI's ability to act as a senolytic in the testicles, or looking at its ability to clear senescent Leydig cells, or the cells that produce testosterone. And in this study, FOXO4-DRI was impressively found to lower the amount of senescent cells and thus improve testosterone production in these mice. Then through a similar mechanism of reducing testicular senescence, another study demonstrated FOXO4-DRI's ability to improve spermatogenesis and sperm quality. Then we also have a couple of studies on FOXO4-DRI decreasing senescence in lung tissue, and this was shown to inhibit progression of pulmonary fibrosis in mice. And then another study on a different FOXO4 blocker found that the compound was able to help decrease senescence in cardiac tissue, which helped decrease heart aging. And then probably the most promising study when it comes to anti-aging and longevity is when FOXO4-DRI was given to otherwise healthy aged mice. And in this study, FOXO4-DRI was found to improve fur density, renal function, and markers of fitness in these mice, all of which signaling an improvement in health span. So overall, we do have multiple studies in aging mice demonstrating FOXO4-DRI's ability to clear senescent cells, and this having a direct impact on health outcomes, including even for longevity and anti-aging in general. However, that's pretty much where the evidence stops as of right now. The only human study we have is one in vitro study on human cells in which FOXO4-DRI was found to clear senescent cells that are found in cartilage. But we have no true in vivo human data. So because of the lack of human studies and because of the fairly low quantity of even preclinical evidence, FOXO4-DRI lands only at number 4. And really, you could even make a case for MOTS-c to be above it. But to me, due to this extremely promising senolytic mechanism, and due to the studies that we do have, I still think it deserves this spot at number 4. Although, of course, we need a lot more studies, including human ones, to really prove its benefit as a longevity peptide. Next, coming in at number 3 is thymosin alpha-1. And thymosin alpha-1 is a 28 amino acid long peptide that is present naturally in our bodies, with the highest concentrations being found in the thymus gland. And to understand how thymosin alpha-1 could potentially be a powerful longevity tool, we have to first understand the function of the gland that it was derived from. So the thymus gland is a very small organ that is extremely important for proper immune function. Specifically, it works to train T cells, part of your immune system, to fight infections or cancer, while also training them to not fight your own tissue or cause autoimmunity. However, unfortunately, the thymus gland consistently deteriorates with age, starting even in early life. And this deterioration then obviously results in less ability for your immune system to surveil for cancer or fight infections, and also results in increased risk for autoimmunity. And this deterioration of the thymus is part of a larger process known as immunosenescence, which is essentially the gradual deterioration of the entire immune system with age. And this deterioration includes not only the thymus involuting, but also more dysfunctional T and B cells, as well as chronic inflammation stemming from these dysfunctional immune cells. So, as you can imagine, the process of immunosenescence can be extremely detrimental to lifespan and health span, not only by contributing to increased risk for cancer, infections, or autoimmunity, but also due to the increased chronic inflammation that's perpetuated by these dysfunctional immune cells. Because this chronic inflammation then drives multiple other chronic diseases, such as cardiovascular or neurodegenerative diseases. And furthermore, this process of immunosenescence is very much intertwined with multiple of the 12 hallmarks of aging, which again even further shows how much immunosenescence can drive the aging process and hurt our longevity. So theoretically, it would make sense if we could find a way to inhibit immunosenescence, we would really be benefiting our longevity, potentially even our lifespan. And this is exactly where thymosin alpha-1 comes in as a longevity peptide, by helping to inhibit or even reverse this process of immunosenescence. And being found largely in the thymus gland, it does make sense that thymosin alpha-1 could have a positive impact on the immune system. And it does so through multiple mechanisms, but chiefly of which are two main ones. One is through activating immune system cells known as dendritic cells by acting on one of their receptors, known as toll-like receptors. This basically downstream increases the cell's ability to surveil for cancer or fight infections. And then the second main mechanism is through activating something known as IDO within these dendritic cells. And this pathway essentially helps promote immune tolerance, essentially shutting down that unnecessary chronic inflammation that can occur. So simply put, thymosin alpha-1 is ramping up the immune system to fight when that is needed, or calming it down to not cause inflammation when that is needed. And through this mechanism, we have multiple human studies demonstrating thymosin alpha-1's ability to inhibit multiple markers of immunosenescence. For instance, in one study in 20 HIV patients whose immune systems were not improving despite standard treatment, thymosin alpha-1 was demonstrated to improve multiple markers of their immunosenescence. And then in a different study in patients with severe COVID-19 infection, thymosin alpha-1 was found to increase thymus output, increase the number of T cells, and thus improve immune system function. And due to this, it was able to decrease mortality rates from 30% in the control group down to only 11% in the group that was given thymosin alpha-1. And then in a different study, in those with prolonged chronic symptoms after a COVID-19 infection, an ex vivo study demonstrated that thymosin alpha-1 was able to restore proper immune system balance, which could definitely help with lowering an inflammatory response after the immune dysregulation caused by COVID. And then outside just restoring normal immune function and improving markers of immunosenescence, which both mechanistically could help with longevity, thymosin alpha-1 also has studies demonstrating its ability to help treat cancer. And this is partly due to its ability to improve immune function, which is super important for eliminating cancer cells. So for instance, in one study in non-small cell lung cancer, thymosin alpha-1, in addition to standard of care, significantly improved survival rates, with a 45% lower risk of death when it was used. And then there are other additional clinical studies showing thymosin alpha-1 having success in liver cancer, as well as in metastatic melanoma. So, all to say, we have multiple human clinical trials on thymosin alpha-1 improving immune system function to help fight infections or fight cancer. And in fact, thymosin alpha-1 has been formally studied in over 11,000 patients, and it's been very well tolerated in these studies. And for this reason, it's an approved drug in over 35 countries worldwide, although the US is not one of them. However, in regards to longevity, where this one is lacking is the direct evidence, even in animal models, for using it directly for longevity and anti-aging purposes in otherwise healthy aging adults. You may have noticed that all of the studies looking at thymosin alpha-1's ability to decrease markers of immunosenescence were in individuals who were already severely immunocompromised, i.e. those with HIV or severe cases of COVID. And almost all the clinical trials in general are on using thymosin alpha-1 as an adjuvant treatment for cancer or to fight infections, without really having any on improving immune system function to lower chronic inflammation or just decrease immunosenescence for preventative longevity purposes. That being said, when used correctly, I still think this peptide has a ton of potential as a longevity peptide just based on the studies we do have. After all, while there still needs to be direct evidence on this, mechanistically it would make sense that thymosin alpha-1 could still inhibit immunosenescence in generally healthy aging adults, despite the fact that most of the studies we have on it decreasing immunosenescence are in those with more severe immunocompromise. And again, if it were able to do this, it could potentially result in lower risk for infection, cancer, autoimmunity, and then lower risk for really any chronic disease that's driven by low-grade chronic inflammation. And we do have some preclinical evidence on this preventative use case. For instance, in animal models, there is some evidence on thymosin alpha-1 being able to prevent cancer. For instance, lung adenoma tumor number was decreased by 15 to 45% when thymosin alpha-1 was given in one mouse study. And breast cancer tumor numbers were also decreased in mouse and rat models when thymosin alpha-1 was given. And furthermore, we also know that those with autoimmune diseases have naturally lower levels of thymosin alpha-1, which to me adds a little bit of weight to the thought of thymosin alpha-1 given exogenously being able to help prevent autoimmune disease somewhat. So overall, this one still has a lot of promise as a longevity peptide, but it's all about using it only when it's needed, i.e. when immunosenescence is at the point when it really needs to be corrected. And as we said, this naturally occurs with age, but when exactly it occurs is really dependent on the individual. Fortunately, we do have some lab markers of immunosenescence that can help guide us on when starting thymosin alpha-1 could be potentially beneficial. And probably the most accessible lab value that we can get is a ratio of certain T cells, or the CD4 to CD8 ratio. Once that ratio becomes less than 1, which happens more commonly when you get past 60 years old, that's when someone is likely struggling with immunosenescence, and thus thymosin alpha-1 could potentially be a good add to a longevity stack. And then outside of this, if you're someone with a history of autoimmune disease, cancer, or frequent infections, then thymosin alpha-1 also could be a good add for you for longevity purposes. But of course, this is really just educational, and you would have to have a further risk-benefit analysis discussion with your doctor, and that's once this one becomes FDA approved. Coming in at number 2 is Epitalon. And Epitalon is a tetrapeptide, or a peptide that is 4 amino acids long. And it's a synthetic peptide derived from something known as epithalmin, which is an extract from bovine pineal gland. And the pineal gland is a small pea-sized structure in the brain whose main function is to produce melatonin, which regulates the circadian rhythm and acts as a pretty powerful antioxidant and neuroprotector. So being derived from the pineal gland, it makes sense that one of Epitalon's main mechanisms is to help restore melatonin production and the circadian rhythm. And in multiple studies in aged monkeys, Epitalon was found to significantly improve melatonin production and help better regulate cortisol, both signaling better regulation of the circadian rhythm. And when it comes to Epitalon's role as a longevity peptide, this ability to improve pineal gland function is super important because the pineal gland calcifies and then deteriorates with age, just like the thymus gland. And this deterioration results in less production of melatonin, which dysregulates the circadian rhythm and provides less protection against oxidative stress. And furthermore, it's thought that this dysfunction of the pineal gland can also further drive aging on its own. And this is due to just how important melatonin and the circadian rhythm are for regulating other hormonal and immune system functions. For instance, it's also very important for metabolic function, which is partly why Epitalon was also demonstrated to improve markers of insulin sensitivity in the aged monkeys, in which it also improved circadian rhythm function. So again, Epitalon restoring pineal gland function and improving melatonin production and thus their circadian rhythm is a super important and exciting mechanism for its case as a longevity peptide. However, Epitalon has a few other mechanisms that might be even more important important for its positive effect on longevity. First is its ability to act as a very powerful antioxidant. And we already talked about how Epitalon increases the production of melatonin, which is also an antioxidant, but Epitalon itself acts as a very strong antioxidant, and it improves your own body's ability to produce further antioxidants. Then the next mechanism that Epitalon also has is the ability to stabilize DNA and also positively regulate epigenetics, or essentially positively regulating how genes are expressed without changing the structure of the genes themselves. And since genomic instability and epigenetic alterations are hallmarks of aging, Epitalon's ability to inhibit them further adds to the case of using it for longevity. And then finally, and maybe most excitingly, Epitalon also has the ability to lengthen telomeres. And shortening of telomeres, or the protective endcaps of DNA, is also one of the hallmarks of aging. So again, the fact that Epitalon has been shown to increase the length of telomeres in mammalian cells is super exciting when we're thinking about using it for longevity purposes. But through all these mechanisms, we have some pretty exciting preclinical data on using Epitalon for longevity purposes, and specifically for lifespan extension. For instance, epithalmin, again, that pineal gland extract that Epitalon comes from, has been studied in multiple organisms for lifespan extension purposes. It increased the average lifespan by 16% in fruit flies, by 11 to 31% in multiple strains of mice, and by 25% in genetically heterogeneous rats, which is just super impressive. And then in the fruit flies, in one of the strains of the mice, and in the rats, epithalmin was also shown to increase maximum lifespan by 6 to 14%. And again, this was from the full polypeptide extract, epithalmin. So we can't 100% translate this data to Epitalon because epithalmin could contain other bioactives outside of just the 4 amino acid sequence that is Epitalon, and those other bioactives could be helping drive some of this lifespan extension. However, it is definitely still a positive sign for Epitalon when it comes to lifespan extension, and Epitalon has some of its own data for this purpose as well. For instance, Epitalon was found to increase the average lifespan in fruit flies by 11 to 16%. And although it failed to extend the average lifespan in one specific strain of mice, it did increase their maximum lifespan by 12.3% and increased the lifespan of the last 10% survivors by 13.3%. And this same study brings up another potential benefit of Epitalon when it comes to longevity, and that is potentially inhibiting cancer. In this study, although they did not find any difference in total number of tumors when Epitalon was used, they did find a 6-fold decrease in the risk of leukemia in the group that was given Epitalon. And then in a different study on a different strain of mice, Epitalon was found to decrease the percentage of mice with a malignant tumor from 10.7% in the control group to only 4.9% in the group that was given Epitalon. And the same study noted that there was no metastasizing tumors in the group that was given Epitalon compared to multiple in the control group. And finally, in a different rat study, Epitalon was found to decrease colon cancer cases when both the control group and the group given Epitalon were both exposed to carcinogenic chemicals. And all this data on lifespan extension and cancer inhibition, along with the exciting mechanisms, are exactly why Epitalon makes it high up on this list. However, just like FOXO4-DRI, it's important to note what we're lacking here, and that is really any human data. So obviously, to really prove any of these benefits, we really need some real human clinical data. But given its preclinical evidence, I'm still really excited about the potential of this one. And while we don't have any human evidence on Epitalon, we do have one on epithalmin, again, that full bovine pineal gland extract. And this Russian study demonstrated that an annual 10-day course of epithalmin, repeated for 2 years, resulted in a 1.6 to 1.8 fold decrease in mortality rates compared to the control group. And then when epithalmin was combined with a thymic peptide bioregulator and given for 10-day annual cycles for 6 years, there was found to be a 2.5-fold decrease in mortality rate compared to the control group. And then in the same study, epithalmin alone was also found to decrease rates of heart disease, high blood pressure, and osteoarthritis. So while this is promising data, it's only one study and it's on epithalmin, not Epitalon. So we definitely cannot assume safety or efficacy for either, and especially not Epitalon as of right now. But the promise for Epitalon for really everyone in the aging population is still pretty huge to me. So I'm really looking forward to human studies on Epitalon in the future. And this would be great because Epitalon is much more reproducible and available compared to epithalmin, which is the full extract, which is technically then a biologic and has a lot of logistical issues when it comes to its widespread use. And then finally coming in at number 1 are GLP-1 receptor agonists. aka your Semaglutide, Tirzepatide, or Retatrutide. And I had to group all these together at the top because if I didn't, all the different forms of GLP-1 agonists would take up spots 1 through 5 on this list. They are just that impressive. So I'm planning a video soon where I'm going to compare the different GLP-1 agonists. However, here we're just going to talk about them all grouped together, despite the fact that Tirzepatide, for instance, also activates GIP receptors. And Retatrutide also activates both GIP and glucagon receptors. But overall, for GLP-1 agonists as a whole, everybody knows about their insane impacts in individuals who are overweight or with diabetes. And this is partly due to GLP-1 agonism or activation causing significant weight loss and significant improvements in insulin sensitivity through multiple pathways. And specifically in regards to longevity, for those with diabetes, cardiovascular disease, or heart failure, there have been multiple meta-analyses of up to 100,000 patients which have demonstrated that GLP-1 agonists result in a 12% lower risk of all causes of death, despite many of these individuals already being on other drug regimens prior. And then in individuals with obesity but no diabetes, the results are even more striking, although the data is slightly less rigorous just given less studies. But in comparison to no intervention at all in obese individuals, GLP-1 agonists were associated with a 77% lower risk of all causes of death in one cohort study, i.e. it wasn't a randomized controlled trial. And then in comparison to other anti-obesity medications, GLP-1 agonists were associated with a 51% lower risk of death from all causes. So if you are someone who is overweight or has diabetes, then this is hands down the best peptide for longevity. But not only that, it's probably better than any other pharmaceutical or supplement that you could use to promote better lifespan or health span. But interestingly, there's emerging evidence that might point to the fact that GLP-1 agonists could benefit those who are not overweight and don't have diabetes. For instance, recent studies have demonstrated that some of the positive effects seen in overweight individuals were not just due to weight loss or blood sugar control alone. For example, in one study of 17,000 patients who were overweight and had prior cardiovascular disease but no diabetes, they found that semaglutide resulted in a 20% lower risk of major cardiac events. But only 33% of this benefit was found to be mediated through change in waist circumference. And there was no association with the amount of weight loss recorded at week 20 and future cardiac events, which is all to say that there seemed to be a very significant benefit towards lowering cardiovascular disease risk that was not just from semaglutide reducing waist circumference or causing weight loss, which truthfully makes sense because GLP-1 agonism has multiple effects outside of just working in the brain to decrease appetite or control energy storage or to improve blood sugar regulation. So there are multiple effects to talk about that specifically add to the case of using GLP-1 agonists as a longevity peptide. And many of these effects directly work on the hallmarks of aging themselves. So the first additional effect of GLP-1 agonists to talk about is its insane anti-inflammatory actions. And this effect occurs through multiple pathways, but it significantly lowers both systemic inflammation and tissue-based inflammation. So for instance, the lowering of blood vessel inflammation and inflammation in the kidneys is probably part of the reason why GLP-1 agonists have been shown to be beneficial in kidney disease or cardiovascular disease. Then the second additional mechanism to talk about is its neuroprotective effects. And this is due to not only lowering brain inflammation, but also due to promoting neurogenesis and inhibiting neuronal cell death, along with several other neuroprotective mechanisms. And this is partly why GLP-1 agonists have been associated with a 45% lower risk of dementia in those with diabetes and/or heart disease. But other glucose-lowering therapies were not associated with any decreased risk of dementia. And then the next mechanism is that GLP-1 agonists have also been shown to improve mitochondrial function and decrease oxidative stress, which helps to not only inhibit multiple chronic diseases, but also helps inhibit the aging process itself. And then finally, GLP-1 agonists have also been shown to work on multiple other hallmarks of aging outside of just chronic inflammation and mitochondrial dysfunction. And this includes reducing cellular senescence, improving autophagy, maintaining proteostasis, and better regulating nutrient sensing. So overall, because of all of these anti-aging mechanisms, GLP-1 agonists have now started to be studied in animals specifically for anti-aging and longevity purposes, even in these animals who are not diabetic or overweight. For instance, one mouse study gave a GLP-1 receptor agonist, exenatide, to the mice starting at 11 months of age, which is equivalent to a human age of about mid to late 30s. However, they used very low doses of the GLP-1 agonist so that it did not impact food intake or weight. And despite there being no change there, the mice were found to have multiple improved molecular markers of aging, along with improved physical function markers as they aged. And interestingly, the same study gave a different group of mice rapamycin, which is the most studied lifespan extending agent, and what they found was that the molecular anti-aging changes caused by rapamycin were very similar to the molecular changes that were found with the GLP-1 agonist. So this is extremely exciting data demonstrating that, at least in these mice, there are longevity and anti-aging benefits that come from using a GLP-1 agonist despite there being no change in weight or food intake, which again further demonstrates the additional longevity mechanisms of GLP-1 agonism outside of just weight loss alone. And interestingly, this study also notes that a lot of these anti-aging mechanisms come from GLP-1 agonism in the hypothalamus, resulting in somewhat of a brain-body axis of aging modulation. Furthermore, it's also worth noting that the same study did not find any anti-aging benefit when the GLP-1 agonists were given to young mice at a human equivalent age of mid-20s up until their mid-30s. So while there obviously now needs to be human studies looking directly at anti-aging effects in normal weight, healthy individuals, I think that this study, along with all the longevity mechanisms we talked about, really give hope to the fact that using a very low dose of a GLP-1 agonist in your late 30s and older may provide a powerful longevity benefit. Now I want to go more in depth on a few peptides that can help with tissue healing or mitochondrial function. Well, check out this playlist here, and then also subscribe for more peptide videos coming soon.